In this video, we're going to talk about solving literal equations. Are you wondering what literal equations are? Well, they are equations that contain more than one variable. We call these literal equations formulas, and we can use formulas to help us solve application problems. In our first example, you might recognize V equals LWH. That's volume equals length times width times height. And the way this literal equation is given, it is solving for volume. We would like to rearrange this and solve for one of the different variables, and that would be for height. So in order to do this, we are thinking about the properties of equality that we talked about in our last video. So think about how height is being connected to the other variables, L and W. If they're all written in a row this way with no symbols in between, that means they are all being multiplied together. So to undo multiplication, we're going to divide. So if we have V equals L times W times H, to eliminate length and width, we're going to divide by length and width. Well, that means that both sides of the equation must be divided by the exact same thing. So we end up reducing length and width on the right, and notice we're left with the variable we wanted. So volume divided by length times width is equal to the height. So in order to rearrange these formulas or literal equations, we're simply applying the properties of equality. In example 2, you might recognize 4x minus 3y equals 10 as the equation of a straight line. We want to solve for y. So when we do that, we're actually transforming the standard form equation into the slope-intercept form of the line. So let's find y. Y is written right next to a negative 3. That means it's being multiplied by a negative 3. And then we also have a positive 4x, so that means it's being increased by 4x. So we've identified two operations that need to be undone. So I'll take away 4x from each side of the equation first. That means 4x is eliminated from one side and collected on the other. I have negative 3y now equals negative 4x plus 10. The final step is to isolate y. It's being connected to the negative 3 with multiplication, so I need to divide that term by negative 3. That means every term in the equation is going to be divided by negative 3. When I simplify, I am left with the variable we are trying to solve for. Y equals negative divided by negative will simplify as positive 4/3 x. Positive 10 divided by negative 3 would be a negative 10/3. And this is our answer. We have rearranged the given equation to solve it for the other variable. In example 3, we have A equals 1/2 times the quantity capital B plus lowercase b times h. Capital and lowercase b are two different variables, so do not combine those. We want to rearrange this formula or literal equation for capital B. So here's where it's located. So we have several things we'll need to take care of here. We've got parentheses, we've got a fraction, we've got multiplication. So it might be easiest to eliminate the fraction from the equation first. 1/2 is our fraction. Since 2 is the denominator, multiplying by 2 would eliminate that fraction. So both sides of the equation are going to be multiplied by 2. When that happens on the right, you can see how the fraction eliminates, and we're left with 2a now equals capital B plus B quantity being multiplied by h. So I could take care of that distributing right now. H is multiplied by capital B to give us capital BH, and then h times the lowercase b. So that's BH. Again, identify which of these variables are we trying to solve for, and that's capital B. So what it looks like we need to do is undo any operations happening to capital B. That would be multiplication of h has to be undone, and addition of BH needs to be undone. So I'll start by subtracting BH from each side. That leaves me 2a minus bh. Those are not like terms, so I can't actually subtract them. I can only write down that expression of subtraction equals capital BH. So now we just have one step remaining. If we're trying to isolate capital B and it's multiplied by h, division of h will help us to eliminate h. So every term is divided by h. What we notice in the first term, 2a divided by h, there are no common variables there. So the 2a divided by h will remain. Next we have subtraction. Notice how h appears in both the numerator and denominator, so that actually reduces, and we're only subtracting lowercase b. On the right-hand side, h reduces, and we are left with capital B, and that's the variable we were trying to solve for. So here is our literal equation rewritten and solved for capital B. You might recognize example number 4. This is temperature conversion between Celsius and Fahrenheit. And here we have C is equal to 5/9 times the quantity of F minus 32. So we want to rearrange this literal equation to solve it for F, or Fahrenheit. Notice that we do have a fraction, and only one term in this equation has a fraction, so we'll use 9 as our lowest common denominator to clear the fraction. So if the lowest common denominator is equal to 9, we're going to multiply both sides of the equation by 9. So 9 times c would equal 9 times this fraction, 5/9, multiplied by the quantity f minus 32. So what happens is the 9's are going to reduce, leaving us 9c is equal to 5 times the quantity f minus 32. With parentheses, we'll need to clear by distributing 5 to each term in this quantity. So we'll end up with 9c equals 5f minus 5 times 32, and that's 160. What we are trying to do is isolate the term with f. So we can see two different operations are happening. F is being multiplied by 5, and it's going to be decreased by 160. So if we add 160 to each side of this equation, that will help us to get the term with f isolated. So adding 160 to both sides of the equation results in 9c plus 160 now equals 5f. So the only operation happening to f now is multiplication of 5. Division of 5 is the opposite. So every term in our literal equation will be divided by 5. So we can reduce, and we can clearly see that we are left with f equals something. So reduce wherever possible. 9 and 5 are not going to have a common factor, so that term remains 9/5 C. 160 divided by 5, that will be positive 32. So here we have an equivalent equation, but solved for a different variable from the original. So when you have C equals, it's helpful to use that formula if your input is Fahrenheit temperature. Whereas in this second equation, if you have Celsius, this would be the easier formula to use. In example 5, we're given x equals y plus z divided by 10. We're trying to solve this equation now for the variable y. Since y is in the numerator of a fraction, we're going to have to clear the fraction from the equation in order to isolate the variable y. 10 is our only denominator, so the lowest common denominator must be 10. To eliminate the fraction, we simply multiply each side of the equation by 10. So 10 multiplied by x would equal 10 multiplied by the fraction, which was y plus z divided by 10. You'll notice that 10 divided by 10 eliminates. So we're left with 10x now equals y plus z. To isolate the variable y, we simply subtract z from each side of the equation. So z will eliminate from the right-hand side, and then it collects on the left. We do not have like terms on the left, so the best we could do is to write 10x minus z equals y. Now this equation is equal to y equals 10x minus z, so either way you prefer to write it is acceptable. We do have a couple of application problems to help us see how we ever would use literal equations. If Portalis reaches 105 degrees Fahrenheit or higher, what are the equivalent temperatures in degrees Celsius? So we can use the formula from example 4 that we just were working on earlier, and that was C, or Celsius degrees, are equal to 5/9 times Fahrenheit degrees minus 32. So what were we actually given in our scenario? 105 degrees Fahrenheit. So that's going to substitute for Fahrenheit in the formula. C now equals 5/9 times 105 minus 32. Now don't forget about the order of operations. We need to use the order of operations to finish this problem. So we would start inside parentheses with 105 minus 32. We're going to have 73. So if it helps you, you could write that as 73 over 1. So the Celsius temperature, 5 times 73 divided by 9 times 1. So 5 times 73, 15, okay, 135 and 1 more makes 365 divided by 9. And we're going to have a repeating decimal here. So we know that 105 degrees Fahrenheit is about 40.5 degrees Celsius. In another situation, it says when the wind chill makes it feel like -3 degrees Celsius in Chicago near the lake, what is the equivalent temperature in degrees Fahrenheit? So now we're going to use our formula that was rearranged for Fahrenheit because our input value now is in Celsius. So instead of C, we're using -3. The Fahrenheit temperature would be 9/5 multiplied by -3, and then we will add 32. So the order of operations tells us to do this multiplication first. Fahrenheit now would equal 9 times -3 would be -27 divided by 5, and then add 32. So you could use your calculator and take -27 and divide that by 5. The last step, add 32, and your calculator will perform the order of operations for you. Just don't forget that the 27 is a negative number. And our answer will be in degrees Fahrenheit. You should get about 26.6 degrees Fahrenheit for that answer. The last few examples deal with calories and grams of carbohydrates, fats, and proteins. So the calorie count C of a serving of food can be computed based on its composition of carbohydrate, fat, and protein. So here is the given formula. And it tells you that H is the number of grams of carbohydrate per serving, F is the number of grams of fat per serving, and P is the number of grams of protein per serving. So we have a serving of cashews that contain 14 grams of fat, so F must be worth 14. 7 grams of carbs, so H is worth 7, and 6 grams of protein, so P must be worth 6. So what haven't we been told? We know F, H, P, we don't know the calories. But if we substitute these values into our literal equation, or our formula, we should be able to compute the calories. So the calories are equal to 4 times the carbohydrates, which is 7, plus 9 times the grams of fat, which is 14, plus 4 times the grams of protein, which is 6. So we end up with 28 added to, how much? 36, 126, add 24. So the calories would be 28 plus 126 plus 24, and that's about 178 calories for that serving of cashews. We're going to use the same formula, but this time we're given different information. A serving of raisins contains 130 calories. So this time we're given the calories. C equals 130. 31 grams of carbs. So H is 31. And it says raisins are a fat-free food. So that means fat would be 0 grams. So that's important to know. The question is how much protein is provided by this serving of raisins. So if we are not given a value for P, then we need to keep the variable. Let's substitute what we were given then. Calories are 130. 4 times the carbs, so 4 times 31. 9 times fat, that's 9 times 0, added to 4 times the protein. And protein we don't know, so that's 4 times P. If we simplify this a bit, we'd have 4 times 31, and that's 124. 9 times 0 would be 0, so we don't need to write that. And finally, 4 times P is 4P. Now there's no need to keep writing the parenthesis. We know that 4P also implies multiplication. So notice that 2 of the terms are constant terms and only 1 of the terms is a variable. So 4P is going to remain where it is, and we somehow need to move 124. So the subtraction property of equality is going to help us out here. Remember, that's the same as adding a negative number. So 130 minus 124 gives us 6 equals 4P. In order to isolate P, we need to eliminate multiplication of 4. Division of 4 would be the opposite. So now 6/4, we can reduce that, right? Both of these numbers are divisible by 2. So 6 divided by 2, slow down, be careful on that one, is 3. And 4 divided by 2 is 2. Now, if you leave the answer as 3/2, remember it is in grams, so you might find it more useful to take 3 divided by 2 to get P, or protein, equals 1.5 grams of protein. And our last example today, just to show you another format, how answers or a problem might be presented to you, and that's in table format. But we're still given the value of some of the variables. We're using the same literal equation. Carbohydrates are 21 grams for yogurt. So what we're looking for then, carbohydrates here, we're going to substitute 21 grams for H. Protein, 5 grams, so that is actually telling us what to substitute for P. And calories are 120. So we know the calories, or C, will be substituted with 120. So I have 120 equals 4 times 21 plus 9 times F. Notice we were not given F, so we need to keep that variable. Last, we have addition of 4 times protein, and that was 5 grams. So 120 now equals 84 plus 9F plus 20. So we actually do have some like terms to combine this time on the right-hand side of the equation. 120 would equal 84 plus 20. And 84 plus 20 is going to make 104 plus our 9 times F. So I'll subtract 104 from each side. 120 take away 104, and that's going to leave us 16 equals 9F. And finally, you probably realize you're going to have to divide by 9 here. So if we take this answer of 16/9, we want to take 16 and divide it by 9, and that will give us our grams of fat. So 1.8 grams is how much fat is in this serving of yogurt.